Okay, so welcome back to the second part of the difficult integral questions for A-level. And so in the first video, we went through integration by parts and we went through some of the reverse chain rules. And in this video, we're going to go through some difficult trig questions and also substitution. Okay, so first of all, we're going to look at sine squared x. Okay, so for sine squared x is similar to cos squared x. What we're going to have to use is the double angle formula. And more importantly, the cos 2a formula. Okay, so we know that cos 2a is equal to cos squared a minus sine squared a. Okay, in fact, it's got three different ways we can write it. We can either write it like this, or we can write it like 1 minus 2 sine squared a, or in terms of cos squared, we can write it as 2 cos squared a. So there's three different forms of writing the cos 2a formula. We're looking for the sine squared, we're substituting the sine squared, so we're probably going to have to use this second one here. Okay, so rearranging for sine squared a will be equal to 1 minus cos 2a, and that's all over 2. Okay, so when we integrate sine squared a, we can just rearrange or substitute it for this term. So we can say that it's equal to integrating, I'll bring the 1 over 2 outside, so it's just left with 1 minus cos 2a. Okay, in this case it's x, so I'll write it as x. Okay, and that's all with respect to dx. So that's, if we were to integrate this, we'll have 1 over 2, and then in the brackets we'll have x. Integrating cos, we get minus sine, but we got a 2 as well, so we're going to left with minus 1 over 2 sine 2x, like such. Okay, and then plus the c. If we were to try and integrate cos squared a, for example, cos squared x, then we're going to have to use this third way of writing, okay? But it's the same method. Sine squared and cos squared, we're going to have to use the cos 2a formula. Right. Okay, let's take a look at the cos squared example. Okay, so this is the integral of cos squared 4x. So as before, we're going to have to use the cos 2a double angle formula, okay? And we know that's equal to, in terms of cos squared, that's going to be 2 cos squared a minus 1. So in this case, our a, we can rearrange for this cos squared a to be equal to cos 2a plus 1, and that's all divided by 2. In this case, our a is equal to 4x, so we're going to be, if we're to integrate it, we can replace it as, once again, bringing the 1 over 2 outside, we're going to have cos, because our a, in this case is 4x here, is going to be equal to cos 8x plus the 1. Okay, and that's, we do dx like this. And integrating this, we have 1 over 2, and then in brackets, 1 over 8 sine 8x plus the x, and then we have plus c. Okay, so just be very careful what our a is in the question, okay? But for sine squared and cos squared, we're going to have to use the double angle formula, more specifically the cos 2a formula. Okay, let's look at another example. So let's look at this sine 10 sine 3x cos 3x, okay? This is an example of using the other double angle formula, more specifically the sine 2a formula. Okay, so the sine 2a we can rewrite as 2 sine a cos a. So if you notice, our a in this case is 3x, right? Because at the same angle here, 3x, 3x. So we can rewrite the top term, if we were to write that as 10 sine 3x cos 3x, that would be equivalent to 5 sine 6x. Okay, so we can simply integrate 5 sine 6x. So integrating sine, we get minus cos, so we'll be left with minus 5 over 6 cos 6x plus c. Okay, so when the angles are the same, 3x, 3x, then we can use the sine 2a formula. Okay, what about when the angles are not the same? For example, this equation. So you can see here, it's 8x and we've got an x here. In this example, we can't really use the sine 2a equation, but we can use a compound angle formula. Okay, so what I mean by compound angle formula, sometimes you might know as an addition formula for cos a plus b. We know cos a plus b is equal to cos A cos B minus sine A sine B. Okay, so for our A and B, we have to try and get x, 8x and x. Okay, so we can say that A is equal to 8x and B is equal to x, in which case we get cos 8x plus x is equal to cos 8x cos x minus sine 8x sine x. As you can see, we got this term here, the cos 8x cos x, but we have another term which we do not want. So a way of not getting rid of it is using the cos 8x minus x. Okay. The reason behind it is if we were to expand it, we get cos 8x cos x, but this is negative, so this would now turn to positive sine 8x sine x. Okay, so hopefully you can see that if we were to add or find the sum of these two terms here, okay, so we would add cos 8x plus x plus the cos 8x minus x, then these two terms here would cancel each other out because it's the same term as plus minus, right? And we're just left with two lots of cos 8x cos x. Okay, we can simplify this a bit, so it's cos 8x plus x we can rewrite as cos 7x, sorry, cos 9x, sorry. Okay, and plus cos 8x minus x, that would be cos 7x. And that's equal to 2 cos 8x cos x. So you can see here, we've got 2 cos 8x cos x. Our original interval is the same term, but it's just a 6 now, okay? So all we have to do is integrate 3 lots of this term. So 3 times cos 9x plus cos 7x. So this is a much easier term to integrate, but that's just going to be 3, and then in brackets we're going to have 1 over 9 sine 9x plus 1 over 7 sine 7x plus the c. Okay, so whenever the angle here, the angles are not the same, we can use the compound angle formula. If we were given a question, for example, where we have like sine 5x cos 3x, in this case we'll have to use the sine a plus b compound angle formula, okay? Because we want the order is very important. Because they are sine cos, we're going to have to use the sine a plus b formula. Because this is the cos one, we can use the cos a plus b formula. So it's important to note what order the trig terms come in, okay? And then use the right compound angle formula accordingly, okay? Okay, so moving on, this question has both all the methods we've learned so far, okay? So it's got a bit of both the double angle formulas. So this may seem a bit tricky to do, but we just want to simplify a bit, okay? So we'll take the 2 out, okay? And if I rewrote it, because they're both squared, I can rewrite it as sine 2x cos 2x all squared, like such, okay? So if I just look at this term here, sine 2x cos 2x, because they're the same angle, we can use the double angle formula, more specifically the sine one. So I can rewrite that as, well, that's going to be 1 over 2 sine 4x, and that's going to be squared. Okay, so we've reduced it or simplified it much easier. So we're squaring it, so this term 1 over 2 becomes 1 over 4, and bringing it outside, we'll have 2 over 4 integrating sine squared 4x. Okay? Right. We've got a squared term, so we know when we have a sine squared or cos squared, we're going to use the double angle formula, the cos form. Okay? And we know that cos 2x is equal to 1 minus 2 sine squared x. Okay? So I can rewrite that as 2 over 4 sine squared x, so it's going to be 1 minus cos, in this case, our a is 4x, so it's going to be 8x cos 8x over 2. Like such. Okay, I'm going to take the 2 out again, so we're going to be left with 1 over 4 on the outside, and we're going to all have to integrate is 1 minus cos 8x, like such. And so this is very simple. We're going to get x minus 1 over 8 sine 8x plus c. Okay, so when you get questions like this, don't get too flustered. Just try and see, are the angles the same? If they're the same, then we can use the sine 2a formula. If they're different, then we can use the compound angle formula. And then we can also use the cos 2x when we reduce it to sine squared. Okay, so that's all the trig integrals. We're now going to look at substitution. In most questions, they will give you the substitution, okay? But sometimes they might not give you what you should substitute. So we need to try and find our own substitution values. The main goal of trying to find it is, well, we want to, for example, if you get fractions like such and such, we want to reduce the denominator to one term. In this case, it's x plus 1, but we want to reduce it to one term. So a way we could do it is say, oh, let's let u equal to x plus 1. We know by substitution, we need to replace all the x terms in terms of u. So we need to get this dx term as well. So we can differentiate the u with respect to x, getting du by dx. And that's just going to be equal to 1. So therefore, du is just equal to dx. We also need to substitute this x term here. So rearranging this u term, we get x is equal to u minus 1, like such. And now we can just go about replacing it or substituting it. So we have u minus 1, and that's over this x plus 1, because we set that as u, is now reduced to one term, and we have du. Okay, so this is a much easier way to, or much easier form to integrate. Okay, because we just divide it, so we get 1 minus 1 over u, and so we know that is just equal to u minus ln natural log u plus c. Make sure that you replace your u back with the x terms later on at the end. So we get x plus 1 minus the natural log of x plus 1. Like such. Okay. This question is very similar. In this case, we've got the root x plus 1. So once again, our goal is to reduce it to one term. So what we can say is, well, if this is a root, I can just say it's u squared now is equal to x plus 1. Why? Because u will now be the root of x plus 1. That's much easier, okay? Differentiating this, we can do implicit differentiation. So we're going to get 2u du by dx, and that's just going to be equal to 1. So therefore, dx is equal to 2 du. Okay, x will be equal to your u squared minus 1. So we just have to substitute it now. So we're going to get u squared minus 1 over the root x plus 1 is just equal to u. So u, and then dx is equal to our 2 du. So 2u du, so I missed out a u here. There should be a u here. And so we get u's here, so we can cancel the u's out like such. And integrating this, well, that's going to be 2 on the outside, and we get u cubed over 3, okay, minus u plus c. And u, we can now replace back with our original u. So it's going to be equal to 2, and then we're going to have the root of x plus 1 all cubed over 3 minus the root of x plus 1 plus the c. Okay, so either way is fine, either form is fine. Just identifying which way or what our u would be is the important part. The main goal you want to try and do is make sure that if we get a fraction like this, we reduce the denominator to one term. That's why I chose u as x plus 1 here and u squared as root x plus 1. Okay, let's look at another equation. So this is now still substitution, but we're going to look at trig terms, okay? So whenever we get sine and cos, what we should know is, or if I was to differentiate sine, we get cos. And if I was to differentiate cos x, we get sine x as well, right? Negative sine x. So our substitution is going to be one of the two, okay? One of either two, okay? So let's just try u is equal to cos x. Right, differentiating this, du by dx, well, that's just going to be equal to, as here shown, minus sine x. Okay, and therefore dx, that's going to be equal to minus 1 over sine x multiplied by du. I'm now going to replace it straight into this integral because there's a reason why we're going to do this. So we're going to have sine cubed x cos squared x times negative 1 over sine x du. You can see here now, this is minus 1 over sine x. One of these sine cubed x, that can be cancelled out, okay? So we can say it's now equal to sine squared x cos squared x du. We now go about replacing these terms. So cos squared x, that's just u squared, okay, as shown here. Sine squared I can replace as 1 minus cos squared as well, like such, using the identity we should all know. So it's going to be equal to cos to the power of cos squared x minus cos to the power of 4x du. We can now replace it in terms of u, okay? So we get u squared minus u to the power of 4 du, which will give us u cubed over 3 minus u to the power of 5 over 5 plus c. Making sure we replace the u back with our initial substitution, because u is cos x. That's going to give us cos cubed x over 3 minus cos to the power of 5x over 5 plus c. Okay, so whenever you're given a trig term to substitute or integrate by substitution, we always want to try and let u equal to one of the two terms, because hopefully they will try and cancel each other out later on. So the next one we're going to look at is this integral here. We now have limits as well, so we need to make sure we change the limits as well as when we do the substitution. Once again, I want to try and reduce this to a single term, so our u, we can say is equal to 1 plus cos theta. We need to get rid of the theta, so we have du by d theta, that's just going to be equal to negative sine theta. Okay, so therefore d theta, well, that's just going to be to minus 1 over sine theta du. As you can see, we also need to replace these limits as I said earlier. So when theta is pi over 2, plugging into our original u equation, we're going to get u is equal to 1 plus cos pi over 2. Cos pi over 2 should be 0, so it's going to be equal to 1. When theta is 0, same thing, u is equal to 1 plus cos 0. Cos 0 is 1, so we're going to be equal to 2. So we can now replace it, okay? So we can say, or the limits, we don't change, just because the 1 is smaller, we don't change the limits. It's 1 to 2, 2 to 1, sorry. And now this sine t theta, you should be able to notice that is 2 theta, right? So we can expand it, saying it's 2 sine theta cos theta. Okay, sorry, 2 sine theta cos theta. And 1 plus cos theta we set as u before, multiplied by the d theta now, we just said, we worked out is to be negative 1 over sine theta du. You can clearly see now we can cancel out this sine theta with this sine theta, okay? So I'm going to bring the 2 out, so we're going to have 2 on the outside, 2 integrating. We now have we have negative 2 in fact actually, negative 2, because we have a negative sign here. We now have cos theta, so I can replace that in terms of u, which will just be u minus 1. So we're going to have u minus 1 over u du. This is going to be equal to minus 2, and in brackets, u over u is 1, so integrating that will just give us u. Minus 1 over u, integrating that will give us ln u, natural log u. Okay? And the limits are from 2 to 1. I can now just replace the limits, so minus 2, we have 1 minus ln 1. Okay? Take away 2 minus ln 2. Okay, so we have negative 2. Ln 1 is just 0, right? So it's 1 minus 2, so we're going to have negative 1. Minus ln 2 will give us a positive ln 2. Okay, and then timesing it by this negative 2 outside, we're going to have 2 minus 2 ln 2. Okay, so the main goal is to try and reduce this fraction into one term. That's why I set u as equal to the whole denominator. And don't forget to change the limits as well. So in this case, in terms of theta, we need to change it in terms of u. Okay, so that's all the trickier integral questions for A-level maths. Hopefully that's really helpful for you guys. If you want any more questions, just comment below, and thank you.